Hello, everyone. Welcome to our webinar around LLM ops and AI agents. We'll get started in a couple of minutes. This is a very sought after, almost sold out webinar. So we're very excited for this. I'm sure everybody is logging in from across the world. Hopefully this is interesting for you guys. We will spend some time walking through kind of the state of the art when it comes to large language models, how they're being applied today in various different use cases, as well as walk through how to create your own custom chat GPT, and lots of fun stuff. And then also walk through this idea of AI agents, how they can be powerful for you. So yeah.
Bindu, your audio is slightly choppy.
I see. Let's see if it gets better. Is it slightly better or no?
It's better now.
Okay, got it. I think I'm gonna just move my mic closer so you guys better. So, hi, welcome. Good to have so many of you here. We're expecting a lot of people, so let's see. Okay, we are going to get started in literally 30 seconds. Again, welcome. And hopefully you will learn a lot about large language models today. Hello from DTLA. Hello, everybody. Welcome to our webinar. I will get started in literally a minute. In the meantime, if you guys want access to to Abacus, here is a special invite code that I'm going to be posting right now on. I'm going to post this on chat as well as in the Q&A section so that everybody can see it. Let's see. I don't know how to post a new question. I guess if I'm a panelist, I can't really post a question here. Kim, do we know how to post a question? I'm going to send a link to you. So we should figure out if we can post this as a question or something like that here.
I just did it.
All right, fantastic. All right, okay, let's get started. I'm going to share my screen. All right, I think all of you can now see my screen. Let's see, I'm going to move this a little bit. All right. Okay, so welcome again, everybody. There is a link that we posted on the Q&A section as well as in chat. We will keep posting that link throughout this webinar, which will help you sign up for Abacus and try out large language models, basically even customize your own large language model, try out what we are calling AI agents, creating your own AI agent and stuff. It's really simple to do. As part of this webinar, the agenda is very simple. I will give you an overview of large language models, the state of the art there, as well as go from there to talking a little bit about AI agents and how powerful they can be. We are at a very important time in the history of, I will dare say humanity at some level, because AI is inflecting. And what I mean by that is we're seeing rapid improvements in these models, what they can do, how they can reason, how they can understand language. The kind of things that they can do even over the last 6 to 9 months has been remarkable in terms of how powerful they are. And, and everybody is obviously very excited, but they're also slightly afraid of this very intriguing and very powerful technology. And with all powerful technology, it can and will be transformational. It depends on how you apply it and how responsibly you apply it, but also how quickly you apply it, because the people who are early adopters of any of this technology are going to be tomorrow's winners. So in a lot of ways, right now is the time to jump with both your feet into AI, understand it, understand how you can apply it both personally and professionally, and start basically co-opting AI to do your dirty work for you. That's what I like to say. Get AI to do all the hard work while you can party or do whatever it is that really pleases you, as opposed to having to do a lot of the work. Okay, so let's get started. So just to begin with, I think this is very obvious. Generative AI has taken off like crazy. Everybody has heard of that term. If you haven't heard of generative AI, you've at least heard of GPT. Our version is called ChatLLM. So ChatLLM is what comes to my mind very quickly, but ChatGPT. I've also, heard a lot about LLMs, which are large language models, and they've done a lot of like revolutionary things. You've seen, if you've played around with ChatGPT, that it seems almost human-like. In fact, it seems super intelligent at some level, right? It can answer questions, it can come up, it has this wealth of information, it knows everything that there is to know on the web, so it just seems really remarkable. Okay, moving on. So LLMs today, they're very delightful. They're really, there are lots of aha moments. You can be like, oh, wow, that's really cool. They are great at generation. So they're very, very good at generating content, whether that be a blog post. You can basically use ChatGPT today, go to ChatGPT and ask it to write a blog post about AI agents, and it's going to write something, right? Or you can ask it to write a blog post about, the Lakers versus the Warriors, and it's going to talk to you about that. And it's not just ChatGPT right now. You can also use Bing to do this, which is hooked up to Microsoft Search, and also Bard, which is hooked up to Google Search. So what that means is, at some level, it has the latest and the greatest information. So you can ask it any question. I like asking questions around, how-to topics, like how do I fix my screen on the phone sometimes, or how do I replace the screen on my phone, or anything which, where you need some how-to help, you can go ask it and it gives you a really good answer. It also actually is good at conversations. So if you want to have any conversation with it, it can do that. The problem with it is it also hallucinates. And for people who don't know what hallucination is, it's basically a really simple thing where it just makes up stuff. It makes up stuff which is not true. So for example, if you have a question which says, how do I do better anger management? It might give you like 9 or 10 reasons which are really on point, which make a lot of sense, but it can make up a new reason which didn't exist and doesn't make any sense. The problem with this hallucination, and when it's making up stuff, is you don't know which stuff is made up and you don't know which stuff is real. And that is actually the single biggest hard problem that LLMs have today. It's something which researchers around the world are working on very much to reduce the amount of hallucination. And when you look at the OpenAI models from GPT-3, 3.5, 4, and fundamentally OpenAI keeps updating their models very regularly, you will see that the hallucinations have decreased a little bit. So it's not something which is insurmountable. So you want to be able to reduce these hallucinations to be a very low percent, because if you don't have that confidence, then you don't know which answer to trust. In fact, you can't trust anything, right? What they're really good at, though, is information retrieval. And what I mean by this is, if you have a bunch of data already, which you know to be mostly true, it actually does a really good job of retrieving the right answer for a particular question. So it's very good at search-based queries, or queries where you want to search from a bunch of content and then summarize that content and present in a way which makes human readable sense. And so therefore, the really, really big market for LLMs is search. We know that search is a multi-billion, if not a trillion-dollar market, mostly dominated by one company right now, Google, and we're going to see a little bit of disruption there in terms of either OpenAI or Microsoft or Google, maybe splitting share over the next few years as we see, these LLMs dominate over time. Okay, so let's talk about a little bit, let's just get into the weeds a bit here and talk about the evolutionary tree of large language models. The original kind of thinking around large language models are, started in around 2017, 2018. A lot of you probably know this. There was a seminal paper called Attention is All You Need, which was released by Google. I believe that was in the 2014 to 2016 timeframe. But that paper was really kind of revolutionary in terms of identifying a novel neural net architecture, which basically, was a transformer. This transformer architecture is the basis of pretty much all large language models. And a lot of these large language models come from that initial architecture. Pretty much everyone uses that. And interestingly, this architecture is also applied not just in language models, it's applied in forecasting, it's applied in personalization. We at Abacus have spent a lot of time training transformers, both for personalization and forecasting. And these transformers tend to learn information. And fundamentally, in large language models, what they're trying to do is what is called next word prediction. So given a paragraph, given a sentence, it's going to predict the next word, and so on and so forth. So what happens is it just basically loops over stuff, right? You basically have a sentence, and then you say, okay, what's the next word? And then you take that response and then send it back into the net, and then you get the next word, and so on. So that's how it works out. The reason why it's really good at question and answering, if you look at a lot of text, like if you look at text that is available on the internet, what happens when you ask a question? What's the next word? The answer, right? And that's why it's really good at like these question and answering type situations, or chatting with you, because it's just predicting what most humans would come up with next. When I say, hi, how's the weather? You could probably say, okay, or how was your day? Okay, a lot of people basically would say the weather's, my day was good, or my day was great. And so the large language model knows that and remembers that. So the one key thing here is the reason that it's called large language model is because it is trained, A, on a large amount of data, but B, more so, it has a lot of parameters. So the neural net basically has a ton of parameters. Before the advent of LLMs, people would speak about parameters in the millions. They'd be like, hey, my neural net has like 10 million or 20 million parameters. Now it's all in the billions. And so basically, when you're training a very large neural net with a lot of parameters, what you need fundamentally is a lot of data. Because each node has to be learned, and as you learn, as it takes as it becomes bigger and bigger, you also need a lot of data to train it. It takes a lot of time, and you also need a lot of compute power. And so what that means is you need data, you need compute, and you need money. So that basically translates to only a few companies right now really kind of training these LLMs. One company, obviously, that everyone's heard of is OpenAI. They got a lot of money from Microsoft in the beginning. And so they spent a lot of that money training a bunch of large language models. And you see in this evolutionary tree, this is the OpenAI's GPT-1, GPT-2, the GPT-J. I mean, this is the tree. This is the branch of the tree here. Similarly, of course, as you can expect, Google has a lot of money. It probably also has most of the AI researchers on the planet today. So, and they are this green branch here. And they have a bunch of models which they've announced to release. Google's been pretty closed about this. We don't have access, or we don't have an API today to any of their large language models. They've announced it, but not many people have access. There's, people who we can access their Palm model through Bard. They've announced a whole bunch of models around Flan and Palm and whatnot, but not a lot of access there. The other company, which has actually done pretty decent work and has actually done a really good job of open sourcing their models, has been Facebook, or Meta, right? And Meta has actually taken this, kind of idea, or basically has approached this whole LLM landscape by saying, hey, what we're going to do is we're going to train models which are very effective. They don't have to be super big. In fact, some of the ones that they've released are not that big, especially the open source ones. We can they've released those. They're not big, but they are trained on a large amount of data. Also, Meta has the very big luxury of having its own data. Now, you could argue that it's a double-edged sword, right? Some of that data is really good. That's what humans produce in some sense. And the AI is consuming what humans are producing, but humans produce good data, quote unquote data, which makes sense, which is clean, which is healthy at some level, but they also produce bad data. which is in some sense misinformation, but also biases, right? You will see a lot of prejudices and biases, which, if you take like a Reddit data source or a Facebook data source, you're going to see a bunch of that. And so this is not just about taking that data and training a very large language model. That's usually what is called a base model. What they typically do after you have that base model is you train another, you kind of retrain that model a little bit with a technology called RLHF, which is reinforcement learning based on human feedback. And fundamentally, what we're doing with that base model, the base model is just like, telling you exactly like what humanity thinks at some level, which, you could argue could get very like raw at a, at a very visceral level. And what we are trying to, what like people like OpenAI have done is they've basically taken a bunch of like questions. You ask the model a bunch of questions, it gives you a bunch of answers. But then you can kind of rank those answers. You can basically say this is good, this is bad, or you can teach it to like, not have biases, teach it not to have prejudices by, actually labeling a bunch of these answers and then feeding that back into the model and retraining the model on that RLHF and basically ensuring that it is much more well-behaved in some ways, right? And that RLHF piece has been central in getting adoption of that model. So as an example of this, a couple of years ago, I think Microsoft released a model, I think it was called Tay or something, and within a day, people had managed to make it very kind of biased and prejudiced and racist and whatnot, and then they had to shut the whole thing down. Now, like OpenAI has learned over time how to make it so that it's more palatable to humans and basically has made it possible for us all to actually benefit from these LLMs. But the good news overall is that there's a lot of these large language models. There's BART, there's GPT-4, there's Llama, there's a whole lot of stuff here. And then as you can see, there are also various different techniques. I'm not going to go too much into this. There's an encoder-only technique, encoder-decoder techniques, and decoder-only techniques for these LLMs. Right now, these decoder-only techniques are the ones where you're seeing a huge explosion of these LLMs. Okay, moving forward. I did want to talk a little bit about open source versus closed source. So one of the things that I know a lot of customers who we have are very concerned about is sending their data over to OpenAI or like using something like that, because there may be some risk. Now, OpenAI has said there's not much, but there may be some risk where the data gets consumed by the model, and then, in the future, that same data can be used for training. And when you use that data for training, you might then have the model hallucinate that data back to you in another, for another question, for another customer, and so on. So there is some risk of that. People are a little, nervous about just using OpenAI for it. And so there is this issue also that given how powerful these technologies are, they're both and how closed source they are. There's a lot of push to make some of these things open source and make it available. Now, there are a couple of challenges to having this open source, right? The first challenge that you have when you open source a large language model, a true large language model, meaning something like GPT-4, which, to be honest, we don't have in open source. We don't have anything of that quality today, partly because a lot of these companies have said, hey, it's dangerous to open source these models. So you open source it, people can misuse it, people can create misinformation from it. It can distribute it. While these large language models cannot distribute the information, they can make stuff up. You could tell it to make stuff up. You could say, hey, make up something about the presidential candidates, and it probably will do that. And then you could potentially use that information, right? So people have been a little kind of like cautious about open sourcing this. The other issue with open sourcing it, like even if, let's say, Facebook or OpenAI just said, hey, here's a 1.5 trillion parameter model, take it and do what you will with it. The problem is running it, just serving it is very expensive. You need GPUs to serve it. It takes hundreds of thousands of dollars to actually serve this in production because these are really big models. And then the third problem is there's just no GPUs left in the world. Everybody is racing to go off and get as much compute as possible, that it's very difficult to get a GPU. So if you're a startup and you're looking for GPUs, or you're looking at an organization, it's not all that simple. It's expensive. It's difficult. Doing kind of like these really large language models can be very difficult. Having said that, We believe strongly in this graph here. Now, I don't exactly know what the scale of the time axis is. Is that like in the next 5 months, in the next 1 year, next 10 years? I don't think it's in the next 10 years. But if you look at your x-axis here, we're talking about over time, we're going to see this almost Cambrian explosion of open source models. We're seeing some of that. I feel like we're somewhere like, kind of like in this early part of this graph, we're still in open source is still below closed source, but I expect the open source to get better and better. And the reasons for this are as follows. The first one is that we're not going to need these really big models, and I'm going to talk through that. So we're not going to need like these 1.5, 1.10 trillion or 10 trillion parameter models. I think over time, we're going to see efficiencies which are 100,000, sometimes even 10,000x, so that even smaller models can get very performant. And then the second reason for this is we're just simply going to run out of data. There isn't that much data that you can train on. People like Google, OpenAI are training on pretty much all of the world's available data, right? So having said that, so far, from the 2018 to the 2021, and this graph is a little bit out of date, but I thought it was a really good graph to show you kind of how these parameters have like really increased. The brute force method has worked, basically taking and making bigger and bigger models with bigger number of parameters. So more data, more tokenization, more larger models basically has been more performant over time, right? Basically, GPT-1, I don't know if any of you ever played around with it. I played around with GPT-1 and 2. It would make no sense. Even the next, next word generation would be very, very iffy. It would, kind of like, do something once in a while, but more often than not, it would just like, spit out something that just comes to its mind, which wasn't coherent in any which way. The first kind of aha model was GPT-3, and that was 170 billion parameters. That actually had a lot of, legs in terms of good text generation. It worked really well. And then we're seeing that go. I mean, people are 10xing this. And so the easy answer here is to just throw all the money at it, throw money at the problem, basically go and train, models which are really, really huge and try to get, as much data as you can and, use that for training. That's the easy answer. Having said that, there are a lot of research companies and labs and startups who are all working on decreasing that size, making it more efficient, and basically getting to models which are smaller in size. So I showed you that, which was actually all these large companies creating these really big models. Now here is how the open source world looks like today. This is a whole bunch of like open source models where the sizes are much smaller. So GPT-4 is rumored to be, 1 or 2 trillion, maybe even 10 trillion. They won't tell us how many trillion, but we think it's in the trillions, right? Whereas, one of the best models that are right now kind of open source, I say kind of because Llama is not completely for commercial use, but it is there for research use, is very decent. And Llama, actually, Facebook released that, Meta released that base model at 4 different sizes, so 7, 13, 33, and 65. 65 is actually pretty hard to run. It's not that trivial. So if you were going to play around or, try some things, you can try the 7 and 13. And then Alpaca, which is actually a version of Llama, which is fine-tuned from data from GPT-3. And that's a very interesting concept I'll talk about. It's also pretty, performant. There's also Vicuna, which, I've heard good things about. We've been benchmarking it too, so we'll see how that goes. But you can see the contrast between the large models from large companies and the smaller models from these smaller, which are open source. So you could maybe erroneously even conclude at some level, like, hey, these small models are not going to be effective or efficient because, we need to go talk to OpenAI. But when you look at their performance, and here, take this graph with a grain of salt, right? This comparison is basically based on a bunch of like questions. I will share that we'll share this whole webinar as well as the slide deck on YouTube, and we will link, I apologize for not having a citation here. We'll link to a citation, but, there was a very informal, I would say, study, which was done where we have a bunch of, where there was a bunch of questions tried out to see how good each model was. And if you assume ChatGPT-4 is at is at that 100% level where it's really good. Here are comparatively the other like models and how well they perform. And you'll see that they aren't that far away according to the study. I have my doubts, but the point being that it's not completely out of the realm of like, okay, it doesn't make any sense to use anything but ChatGPT or Bard. There are still open source models which are actually quite effective. The other thing is this is for generation, meaning when you ask a question, what are the answers? So does it give you the right answer? Does it make sense? That sort of thing. This performance is based on generation tasks. There's also kind of common sense reasoning. This is a little bit more scientific, this study here. And you can see here that GPT-3 and the PaLM models are on top. Those are the really big models. PaLM 540B is the biggest that Google had announced. And, there's a whole bunch of models from OpenAI as well. And then we see the Llama models, the ones I just spoke about, the 713, 33 and 65. And you can see that at the 65 level and even at the 33 level, Llama is like winning actually in a lot of these benchmark studies. And this is various different ways to like see how well these models do on common sense reasoning. And that's also a very delightful piece of these models. They actually are able to reason much like humans are. And part of the reason that they're able to reason is that fundamentally humans evolved language first, right? We're able to communicate with each other. When I say something, you understand what I mean, at least as long as you know the English language, or for that matter, any language. When both humans are actually interacting with each other, if you know the language, it works. And this thing is now trained on language. So in some ways, language is the building block for reason. And so now it can actually reason. It can actually say if A leads to B and B leads to C, then there's a good chance that A leads to C, or that sort of reasoning task it is able to complete quite well. Okay. So now we've got some idea of these large language models. We've seen the open source landscape. We've seen the closed source world. We've seen that it takes a lot of data, it takes a lot of time, it takes a lot of training to get these large language models to be effective. They seem to be very delightful, but they also hallucinate. So that's where we're at. Okay, what's the other issue? The other issue is something called context length. This is actually the key issue. Now, what is context length? So the way to think about context length is very simple. When you look at a model like, say, GPT-4, and you ask it a question on data that it's trained on. So let's say we said, who's the president of the United States? And it'll say, hey, I don't know who the president is in 2023. I have data only from 2021. And maybe, and the president in 2021 was Biden or whoever, right? So it is able to answer factually, or it is able to give you facts from the corpus of data it was trained on. So if you can ask it, what are the 10 best restaurants, or what are good restaurants to go to in Yountville or something, and it'll just actually give you a decently good result. Now, imagine you have a bunch of data which it doesn't know about. Let's just imagine we have a whole bunch of data from your internal wiki. This is my favorite problem to think about. Let's say you have, and we do that at Abacus. We have a fairly, reasonably robust wiki. It has a lot of data. It has a lot of information about how to start up our servers, how to, how to run the system, how to what our culture principles are, and all of that stuff. And so now if I ask it the question, what are Abacus.AI's culture principles? If that is public information that it was trained on, it will actually give you the answer. But let's assume that there was something internal. How do I start Abacus.AI servers? ChatGPT doesn't know the answer, so it doesn't give you the answer. However, what you can do is you can take all of that Confluence data or all of that wiki data, right? It could be Confluence, it could be whatever wiki you have, and give it to GPT-4 or these large language models, as input. And then you can ask it the question, how do I turn on my servers at Abacus.AI? When you ask that question at that particular point in time, it is able to answer that question well, because now it has that information in the context. So that is what context is. So it understands what the context of your question is. And now the problem is, okay, how much context can I give it, right? Imagine if I were Intel or something, some very large company, and that company, let's say, had 10 million pages. Can I now give all 10 million pages to this large language model, and can it now pick up those 10 million pages and like, understand all the content in that data and resolve it? And the answer is no. Why? Because right now it's restricted to only 32K of context length. So you can only, give it that much information as kind of context, and it can then like study or understand that information and then give you answers from that information. The longer that context length is, the harder it is for it to do stuff. So beyond 32K, it'll just basically not even like, it won't even pick that up. So that is fundamentally one of the other big issues with these LLMs, right? Now, again, for the search use case where it's trained on all of the world's data, it works just fine. There's no problem. But now if you want to have to create your own custom ChatGPT, your own custom experience, it's very, very difficult to do because you have to like really give it the right context. So what do I mean by that? For example, if I have a question which says, how do I, let's think of a more esoteric question than how do I turn on my servers? Maybe the question is, what is our work from home policy? Okay, and now I have a million documents, which I have in my wiki, and somewhere in that million documents is the question, is the answer to the question, what is the work from home policy, right? And so how do I know? Now I can't give it all the million documents, remember, because the context length was just 32K. I have to now give it that universe of documents which could have the answer. So I have to now restrict my documents to those few documents which have the answer. Once I know what those documents are, I can send, or that once I know what the content is, I can send that content to something like ChatGPT, and then I can then extract, what my work from home policy is from there. If that makes sense, right? So there are all these steps where you basically have to first do document pre-processing. So you have to take your documents, those million, maybe wiki pages. You have to take that, you have to probably chunk it, you have to extract the text from it. Here's the other bad news. It will not, understand images right now. So OpenAI's work, there's rumors that they do have a multimodal model. Multimodal is basically the ability to take both images and text, but it's not available at least openly to people. And so fundamentally, if you have a lot of images, you can't really build a really good custom ChatGPT experience. But if you have a lot of text, and a lot of wikis are mostly text, and customer service knowledge bases are mostly text. We also have text in like tech support knowledge bases. So a bunch of these types of knowledge bases are very text heavy. We can take that data and we can do can process the document. Usually there's an extraction of the text and chunking of the document to smaller pieces. And then you also have to basically then embed these chunks. So here's what we're basically doing. We're basically going through a step where we're going to first search on these documents to find the universe of content which applies to the question, what is my work from home policy? Once I find that, and it needs to be small enough, it needs to be a maximum of 32K. Honestly, it's actually 5K right now because 32K is not available either, or it's available in beta to a few people. So you just have to reduce your context to a small amount of documents or a small amount of content. And that takes a lot of steps. You would have to, chunk your data. You have to then embed the data. Embed those chunks. And the reason for embedding those chunks is basically you're fundamentally building a search index, if that makes sense. You'll first have to search. So you have your input query, which is what's your work from home policy. You now have to go and take that input query, get the go talk to your search index, get the results, and say, okay, here are the 10 documents which might talk about my work from home policy. Take those results and then send those along to the LLM. Right? So there are multiple steps here, which is the pipelines to get your data. So every day you're going to have new data getting created by a lot of individuals who are using your wiki. So you need data pipelines. Then you have document pre-processing where you're taking those data and chunking it. Then you have to have an embedding model, which takes that chunks and actually, creates an embedding for each of those chunks. And then you want to be able to either have a search index where you can actually do that search, which I just spoke about, or some sort of an embedding lookup. which will actually give us that universe, that smaller universe, as it relates to the search query. And then finally you send it to an API like a GPT-4 or a Palm or whatever to get your results. So that is how hard it is to build your own custom ChatGPT on your own knowledge base. Not a trivial, easy thing. It takes a lot of effort, lots of pipelines, lots of stuff. And that's where, kind of we come in, right? So what we have is something called ChatLLM. And what ChatLLM does, and we have Miles here who's going to give you a really good overview and a demo of ChatLLM. And if you at all want, us to actually build a ChatLLM for you for free, we are doing free POCs right now for a very limited period of time because there's been extraordinary demand for this, but we're still offering, free POCs to build a ChatLLM for you, which is your own custom ChatGPT on your data, right? So, and the idea here is the Abacus system does everything. All you do is point it to a bunch of documents, point it to your wiki, and it will ingest the data, it'll create the pipelines, it'll chunk the documents, it'll create that embedding lookup, and then it'll finally, go talk to some LLM, get you the results. So from data to that, custom chat GPT literally takes a couple of hours. And it's really, really powerful, really easy to do. We are agnostic as to whether you use something like a Palm API or a GPT-4, it doesn't matter. You can use OpenAI, you can use Google, or you can use our own models, which are based off some of these open source models, but we've actually redone them and fine-tuned them and recreated them. So you can use anyone, use any of the models that are available, it doesn't matter to us. The simplest option could just be use OpenAI, right? We'll show you both, how to use both in the system. So it's super easy to do and super easy to set up. Okay, so I talked through a lot of this before already. So what we're talking about is having your node knowledge base. You can, send it to our LLMs, or you can send it to, ChatGPT, and we are able to actually create a chat LLM for you. The arrows in this could be slightly confusing, but fundamentally what we're doing is taking the data, and then creating either an Abacus.AI LLM, which is fine-tuned for you. So it doesn't use GPT-4, it's a custom LLM for your company. Or you can basically use that search index concept that I just talked about, where you chunk the data, get the context, and then send it. So there are two ways you can do this, meaning you can actually create your own LLM, which is fine-tuned on your own data. Okay. So this thing is deployable in hours, so it's really easy. It's easy to train, it's easy to deploy. It will remember, the context. It can search large knowledge bases. It can give you human-like responses. So we'll show you some of those responses, and it can easily get a lot of content, right? So it's very, very simple, very easy to use in terms of taking your data and creating a chat LLM. Like I said, just takes literally a few hours, and it's very simply done. So as I mentioned, finally, we can use these LLM APIs. We can use either a ChatGPT or your own base model. These base models can be fine-tuned on your data. Context length is no longer a constraint. It's better quality than GPT-4, especially if you fine-tune your own models, right? It actually gets to be much better because now you have your own model, which is dedicated to you. So you have that option as well. And then the data will never leave your VPC. So again, two ways you can do this. You can either fine-tune a model for your own purposes, which is your own custom model, or you can actually use ChatGPT-4, but use that search index beforehand. Okay, so after this, Miles will actually show you a presentation of these chat LLMs, both using OpenAI, or using that search index OpenAI method, as well as by fine-tuning our own models. So you can choose whichever way and go whichever route makes sense to you. Again, just drop us an email, go to our website, Abacus.AI, and request a consultation, and then we will set up a meeting with you. We can actually fine-tune and give you a model within a couple of hours, and especially if you get us the data, I promise it takes longer to get the data than to actually train these models. You'll be able to play around with your own version of ChatGPT. Switching, kind of lanes a little bit here, let's talk about AI agents. So these are like fairly new concepts. I don't even really know whether, the community is going to coalesce around the word agents. There's been a lot of talk about using different, words for this. There's something, some people are calling this auto GPT. We like calling them AI agents because these are basically, think of these as AI programs that can collaborate with humans to accomplish various tasks. So, the tasks could be very, very varied. It could be, doing code generation. So a software tool assistant. It could be copywriting and grammar correction. In some cases, there doesn't need to be much, collaboration with the human. In a lot of cases, they are. Like take Grammarly as a classic example. Grammarly doesn't correct your grammar and then automatically it gives you suggestions. You accept the suggestion, or you decide to reject the suggestion, right? So we believe in the next, I would say 1 to 3 years. I don't know after 3 years what happens because things are changing so rapidly. Most AI applications are going to be human AI collaborations. We're going to collaborate with each other to produce the result. AI is going to 10x your abilities, but there is going to be a human in the loop. There's other examples of this is classification, response generation, text generation, knowledge answering, enterprise search, translation, personalized friend. There's a lot of fun example agents. We're going to see some of these examples, especially I really love the ones where you're like chatting with some character or it's a personalized friend and so on. And they can be used for multiple purposes. To run these agents and also to run this whole ChatLLM that I spoke about, you need an end-to-end MLOps platform. Think of it as a chassis. You need an engine, it's kind of, you need an engine on which all of this runs, right? Without that engine, nothing works. So that's kind of what, in a lot of ways, Abacus.AI has done over the last 4 years. Over the last 4 years, we've actually built this very, very high performance, big data, large scale engine, which can take the data, transform the data, chunk the documents, train models, fine tune these models, deploy them, get predictions, the whole enchilada. And you really need that so that you can actually like really connect the dots and create that either custom chat GPT, or you can create that AI agent. So let's talk about AI agents now. So how it works is very simple. You can do any data transform. So you can take a data, transform it in any which way. You can write any piece of code and execute it. So you need an execution engine for code. You can take, you can potentially like create any machine learning model. So as part of Abacus AI, we do have a whole bunch of neural network techniques and auto ML techniques, which allow you to create predictive models, forecasting models, time series models, personalization models. So you can create any ML model. And then finally, the kicker, you get to have, you get to also go call out to an LLM. And that LLM, like I mentioned, could be ours, could be, Google's, whatever, right? And you can ask the LLM to do things. So you can mix and match these things in any which way to create this agent. And to enable all of this, we have a whole bunch of different capabilities. I don't want to get into that right now because we're running out of time. There's a whole bunch of different capabilities you will need to mix and match any of those modules and create an agent. And this diagram here really like summarizes this very well, right? The idea here is we have user code, any user code, any prompt API, I just mentioned this, any data transformation, any kind of like vector matching engines. Basically, these are engines which create these search indexes. You can mix and match these agents. You can chain these little blocks, sorry, not agents, you chain these blocks to create your agent. And that agent can, and you will see this in the demo, Nandish, who's our head of product, is here. He's going to be showing you kind of like how to like create a really simple agent where you can mix and match all of these different modules and really make it much, much more powerful than just having an LLM API. And you can make it do a number of those tasks that I just described. Final piece, when building these things, when building these models, you don't really want, or these agents or what have you, you don't necessarily have to just do it all by yourself. Just like AI was collaborating with us to like do summarization, to write blogs and to do grammar checking and whatnot, we can also get AI to collaborate with us for building AI. right? So that is AI assisted data science. So the idea there is when AI is helping build AI with you. So the way we see the future is data scientists are going to be using AI to build AI. And then they in turn afterwards are also going to be, building some of these AI agents, which in turn will go do stuff, right? So you see AI everywhere pretty much at some level. Now, how is AI going to assist data scientists? For example, we have something in Abacus right now, which is deployed, so you can try it out. It's called AI Chat. There's a little icon, you click on it, and then you can start chatting. And you could say, hey, how does my data look? Can I build a model? How do I go to production? And you can ask questions and it'll respond. And then as you ask questions and it responds, you can start building your AI agent and then you can deploy it, right? So it's a pretty fascinating time. And this is rather early in terms of our system itself. We're like tackling something very ambitious, but it's very intriguing. And we'll have both Miles next, who's going to show off the ChatLLM stuff, and then Nandish, who's going to show off the AI agent stuff. So top line summary here, we believe AI is going to build AI. That's piece one. Two, the AI that it's going to build are going to be either chat LLMs or AI agents. This will cover a gamut of use cases, pretty much all enterprise AI use cases. You will need some sort of a system which actually takes care of all of this so that you can actually, deploy this at scale. We are at the forefront of that revolution today. So you can create your own chat LLM, or you can, create your own agent. You can try all this out. This is so far just PowerPoint but now we're going to actually see the system, see the demo, and you can try all this out. We have a free account that you guys can sign up on. We're going to post this token again. If you can't get to this token or don't know what to do, just apply on the homepage and just request a consultation or request a free demo. We'll give you one of those. I will now pass this on to Miles, our lead customer success and demo engineer, to show off the chat LLMs, and then on to Nandish. Thank you.
All right, perfect. Hey, everyone. As we've been mentioning, gonna start by hopping through some of the different custom chat projects we have to show off today. So I'll go ahead and start sharing my screen and we can get right into things. First, we'll just give everyone just one moment, lay of the land. You do have that link there that I was just mentioning to actually get logged into the platform, try things out. When you do get logged into Abacus, you will see in this home dashboard here, projects are going to be containers for all of your work. We can, of course, go ahead and spin up a new project by hitting create in the top right. And what you'll see is that, we have a number of different solution use cases. For each one of these, you have your own custom, workflows, dashboards, UI, algorithms that will get trained or fine-tuned, of course, depending on which one you select, as well as the option to, grab a modular portion, like a feature store, only use us for monitoring, as well as plug and play your own custom model. Of course, today we are going to focus more on the custom chat side of things. And so we can pretty easily just navigate right down under our NLP section and click into our chat LLM custom chat here. So in this case, when we do click into our use case, you'll see that with this project that's getting spun up here, the UI is going to be wizard based. So it's going to start pointing you along in the right direction, of course, to get started. If you want, you can skip all these down below, but we are going to begin by just creating a new data set within the platform. So a few things I want to mention here when it does come to spinning up data sets within Abacus, grabbing this initial corpus knowledge base that you might want to work with, is it's pretty flexible. So of course, maybe initially, we're just working with some type of local files floating around. Really easy to drag and drop right here into the center. But of course, down the road, we can connect Abacus to really any external cloud location, any database, data lake, anyone might be using. So of course, for the production pipeline state, we can get these connectors authenticated and then can continuously read in more and more of these different documents or text or PDFs, really any type of unstructured document type you might want to use for this custom knowledge base that you're accumulating here. So of course, initial steps here to go ahead and get started. For demo's sake though, we are going to hop into a few different projects just for the sake of time. I'm going to click into an initial text one here. This is going to start us out by looking at a custom knowledge base that's around recipes and ingredients. In a moment, we'll look at another one that's slightly different around games and manuals. And we'll see here with these initial data sets that we're going to go ahead and read in under our recipes and ingredients, a few different ways that we can explore them, as well as look into the raw data itself. I do just want to zoom in a little bit for everyone off to the right. just so you can get a quick glance into the initial data that we're reading in here for this custom knowledge base for our fine-tuned large language model. So you can see here we have some normal text around the title of this recipe, listed ingredients, instructions, all in pretty normal plain text getting fed into the actual platform here. You can see it continues to go on. We don't have to stop and read in this case all of the different instructions about our miso butter roast chicken. But we do have our initial recipes and ingredients that are reading in as data sets. As I was mentioning, text, documents, PDFs, all completely fine to feed in for this initial data set type. And then in long run of things, maybe if you do have different data sets or different documents that are living in different locations, we can combine those into one feature group here within Abacus. So you'll see that feature groups are going to be these logical views that do live on top of our data sets. It's going to be at this level, which you can do any type of combining. So in this case, we're just grabbing, a few different columns that we might want to use that we're using for, recipes and ingredients, and which is what we were just looking at from before within our data sets. And again, as I was mentioning, if there are any, particular data, documents, text that's living in a different location, you can combine it that set. Perfect. So when we do kick off the fine training portion, you'll see that, all I did was I clicked down into our models down below. We can go ahead and hit train at the top right. This is where it's pretty straightforward, and you can actually go ahead and select that list of documents that you want to use for your fine train model. You'll see too, just in general here within the platform, you can have different corpus knowledge bases, that you might want to use for different fine-tuned large language models. Completely fine. You can have them, all in the same project, even if you do want to, or in different ones. And we can just select the specific one we want to use right down below. So you'll see we have a few other, random ones around, our own internal Confluence pages, some other just, open source documentation. But again, we're going to hone in on our recipes and ingredients for now. And this is where we can also, you'll see you have a few different options if you want to play around with them. Will differ slightly from different use case to different use case, but we can go ahead and hit train at the bottom right. So with this initial just N10 example we're going through is going to be fine-tuned on top of our GPT models here. And I can go ahead and click into our dashboard, and you'll see for all of our use cases, including the custom chat here, you do have this prediction dashboard. And this is really just going to be your first landing page where you start to interact with your fine-tuned large language model to see how it's doing, how it's reacting to different questions before you move on to any type of deployment step in production down the road. So in this case, we can ask, I can just go ahead and ask very recipes and ingredients specific questions for that knowledge base that we were just looking at, took a glance at right before in the dataset section. So maybe I can start with what types of rice can I use to make sushi? Go ahead and hit the hit the envelope button, send this out. At this point, we are going to kick off the generative process of course, going through all the different recipes, ingredients, and generating a response for the types of rice that you can make with sushi. And so in this case, we'll just give it a moment and it'll churn out our example. We don't have to read the whole thing, but we can do a quick glance here. You can see now to make sushi, we can use short grain white rice, sometimes called sushi rice, in this case, short grain brown rice. And then it follows up with a description here as far as rinsing it, how we make it, an alternative method, so on and so forth here. All custom knowledge, that is actually from this recipes and ingredients data set that we're just looking at right before. If you did also want sources as far as which different documents, which recipes, which text was used to help generate this response that we're looking at right down below, we do have the optional choice to actually drop down underscores, and you can start to explore, okay, which one of these different recipes, ingredients, the actual sources themselves were helped use from my custom knowledge base that we were just looking at from before for this generative response up above. You'll see too off to the right, we do have a number of different ways that we can start to interact. So if we want to have another conversation, maybe on a completely different topic than the sushi, the rice exactly that I want to use, I can just click new chat. We have a new conversation. I can start asking other questions. In this case, maybe around what are dilly beans, something that I didn't know existed until I started looking around at the different data sets and documents and texts that we're using for our recipes and ingredients for this custom response. You can see down below, we do have our blurb on what our dilly beans are. In case anyone is curious, like I was, you can see that they're a type of pickle green bean used by were made by this different layering, and then so on and so forth. And we have, all these different ingredients like our garlic cloves, dried chili, dill seeds, so on and so forth here to include. We can also, of course, ask different follow-up questions within the conversation around the same topic, context. I don't know, maybe what do I want to know about my dilly beans now? I don't know, what goes well with them? Why not? We can go ahead and send this off. And then again, we have our generative response from that custom knowledge base from before. Something to note too, with the whole end-to-end here, is that, as Bindu was mentioning, this custom chatbot is built on our MLOps platform. So you do have everything connected, pipelines ready to go, where you would have your initial data sets, which is this custom knowledge base that you're, of course, reading. As in a lifetime of the custom chat, you're not going to have the same knowledge base. It's not going to, most likely stay stagnant. It's going to continuously grow as you add more and more documents to it. So you would have this data set automatically refresh, typically on, just a scheduled basis. As you do have your data set refreshing, incorporating the new knowledge and text that you want to use for a general response, this is where you can also have the model fine-tune periodically as well. So in this case, it would fine-tune again, refresh. It's going to take those new documents, into consideration as, we're continually refreshing. And then this, of course, automatically refreshes the large language fine-tuned model we're using for the deployment here. And once you're done clicking through some different conversations, probing the model, asking it different generative questions, as long as everything is looking good, of course, you can start to actually integrate this within, different scripts, applications you might be working on, so that people, end users don't have to log into Abacus to start to, ask different generative questions. You would just have the API, so you can prompt it, from whatever interface you might want to have people use. And then what, something to note too with this, fine tuning, retraining section here, it is doing a fine tuning, process on top of the large language model with your knowledge base. So it's not super taxing or tolling resources heavy, anything like that. Really pretty quick and easy to do, so something to note, it's really redoing this fine tuning step, not retraining, the whole LLM or anything, definitely not needed. Which is why, helps to keep it pretty refreshed pretty consistently. You don't have to worry about, doing it too often or anything like that. And then, of course, down here below, we have our response for what goes well with them. They can be served, a snack, appetizer. They can be paired with a variety of dishes. And we have just a few, examples here. Of course, they were, described within some of the different recipes, ingredients, like our sandwiches, burgers, hot dogs, so on and so forth down below. Perfect. So end to end, quick, just want to do a first introductory example here where we're looking at our recipes, ingredients. This, of course, is just normal text that we're reading, into the platform. And now do want to move on to another knowledge base. It's going to be slightly different. This one is going to be using PDFs instead of, the just normal text and recipes we're looking at from before. And these ones are all looking at different games and manuals in this case. So I'll go ahead and open two different tabs with two different deployments. And what we'll see is that the first tab I just opened up, I think you saw it said game corpus. And this one is going to be actually using Abacus.AI's own internal LLM that we've done, a fine-tuning step on top of. And then this other tab over to the right is going to be using GPT's model in this case as the LLM that we're doing this fine-tuning job on top of. So, just for exercise purposes here, just to compare and contrast some of the different responses we're getting. And you'll see now that the use case differs, where we're not using, GPT to ask any question under the sun. We're really just using it to ask very, specific questions on this custom knowledge base. We really are able to use Abacus.AI's LLM completely fine. It does a really good job. So let me go ahead and ask a few of our different games questions down below for us. We can go ahead and get this kicked off. So first one around maybe how do I win at backgammon? One of the different games that was described in the knowledge base that we're using in this case. And so I'll kick off the jobs for both of these two right here. And we'll just give it one moment here. All right, perfect. In this case, we can see down below, backgammon in this game of two players. In this case, played on, a board like on a board with checkered like pieces, sometimes referring to as stones, consisting of 24 points, separated by this middle, bar. And then it starts to talk a little bit more about the two halves of the board separated by the bar called tables, so on and so forth, really just describing the layout of this board. And then you can see down below it also, describes, in this case, pieces are moved by rolls of the dice, skillful judgment of the player's inner table, thence off to the board. And then we can see finally the first player to bear off all of their pieces wins the game down below. So with the script description, with the GPT response here, I don't know, I would say in this case does okay job where we are looking at first just sort of an explanation of the layout itself. Not super always relevant to I guess winning the game, but possibly. And then you can see down below eventually ends with to bear off the pieces to win the game here. Moving over to, in this case, the custom chat that Abacus.AI is using with our own LLM, we can now zoom in a little bit for everyone's eyes. And you can see that with this response in order to win the game, we first want to understand the game, and understand some different strategies. And so right away, you can see the goal is to move, all of our pieces from your side of the board to the other side, also trying to prevent your opponent from doing the same, which I don't know if anyone has played, backgammon, but of course, very crucial. And then in order to win, we first, learn how to set up your pieces, how to move them, block opponents, and so on. And so once we do have this course, it's a nice basic understanding, we have strategies down below. And you can see, we don't have to read this word by word, but it goes ahead and describes how you would actually block off your own, your opponent there so they can't, escape and actually move their pieces to the other side. And then, enough practice, knowledge of the game, you can, of course, go ahead and master it. So nice. I like this response, of course, a bit more here for, the backgammon as far as a little bit of an explanation, but then also following up here with their strategy for the specific game. And as I was mentioning before, you can also, if you're curious in scores, sources, they can be available for you as well here with our drop-down scores button. And, of course, it's going to highlight in our PDFs some of the different rules here. Cool. So moving on to some other examples, we can go ahead and kick off our new conversation. So in this case, of course, it's going to be a new topic. And I'm going to go ahead and ask, is code names appropriate for children? Go ahead and send this one off. Do the same thing for the Abacus LLM here. In this case, I'll click right on back. It'll take a moment to process, and then we can check out and compare some of these different responses. So in this case, when we look at, is code names appropriate for children? We can see it's a board game designed for players of all ages, skills, so on and so forth. It's fun, engaging game that, can be enjoyed by children, adults alike. Game is designed to introduce logical thinking, basic coding to kids and adults. And so it's sort of interesting with this response for code names with the GPT deployment is that, it does include some interesting, lines here about including, basic coding for kids and adults. In this case, coding isn't a large part of code names as the game. So it's possible that it's looking at this custom, knowledge base from before. And because it does have to do this search portion on top of the LLM, is also, maybe incorrectly grabbing some other games in this case, which do include some basic coding. So a little bit off there when what we're seeing with the GPT deployment. Then you can see, but then it goes on to describe, can easy learn, can be played children as young as 8 years old, so on and so forth there. But something a little bit odd with the basic coding in this explanation. Then we can see down below with the Abacus.AI LLM, it's a little bit at the top, some information about, it's fun, engaging, people of all ages. Well, the game does require players to think logically with creative clues, not too difficult for younger players to understand. It has a note about children as young as 8 years old. And then we have a nice note about codenames as a game of communication, cooperation. In this case, of course, it could be good to have some assistance, help from an adult. And then concluding with an excellent choice for family game nights, can be enjoyed by children as young as 8, as we were mentioning. So does a good job of, giving a nice age that's good for, codenames to be played as. In this case, some note about what might be a little bit difficult for, the specific game with younger children. It doesn't include anything weird about coding skills, which in this case, is most likely from another game, another description like we were seeing with the GPT. So because it is using, of course, the in-house LLM, slightly different approach. In this case, we are going to get some better responses there. But we can do a few more examples here, and then for time's sake, I will finish up so Nandish has a lot more chance to go through some of the different AI agents as they're super interesting. We can finish up here with these last two. So first, how do I win a clue? And then we'll do one more around maybe mystery cooperative games. Perfect. So in this case, we'll just give it a moment in our new conversation, and we can see right down below. To win a clue, each player must correctly guess, identify of the reader by asking yes or no questions based on clues provided. In this case, we can see each clue card is worth 20 points. explanation, between the reader and the player who guessed correctly the reader's identity. Really, hone in on this, quote unquote, reader here for the specific clue game. Special clues, it has one note about that towards the end. And then you can see the first player to collect at least one, tile from each of the 4 categories, in this case, wins the game. So some notes there about, clue in general. But I would say, again, because of the different approach that you need to take with using GPTs, LLM, I think ours does a better job here, where you can see, instead of noting things about the reader, different tiles, points, things that aren't really necessarily honestly related directly back to clue, we can see with the LLM from Abacus, where we really need to identify the murder, the weapon, the room in which the crime occurred, which is really more what clue is about, instead of certain points for specific reader, so on and so forth. Then we can have a little note here to when you need, of course, identify all the different clues. In this case, exactly, when you have the murder, weapon, the room, and of course is, over if you're not able to determine all of that. So again, another example does a great job, and we'll finish up with our last one here, which is going to be, what cooperative games do you recommend for someone who likes mystery? And we'll go ahead and fire this off for Abacus.AI's own LLM as well. And we will go in, I'll zoom in again for everyone. And then we can see we have a just, generative response again, where one cooperative game that might be of interest to someone who likes mystery is this Children, the horror game. And it's a board game where players work together to explore Haunted Mansion, solve the mystery, what happened to these missing children. We have this other one down below. And it's, social card game with Lovecraftian theme, features 6 unique card games. So we have some, 2 different games in this case where there's, some, interesting mystery themes going on. And with this, I do also like the response with the Abacus.AI chat a little bit more, as it does a good, well, this, these are 2 games where there is a mystery theme. We can see with the LM from Abacus, again, not being limited or needing to go through this search step. It has a nice description of a few different games where there is mystery, as well as does a good job of breaking down this cooperative step. So really taking both parts into consideration here. And we can see we have a few different options. So one cooperative game for someone who likes mystery, ghost cards. So cooperative game, you can see where players must work together to defeat this ghost before time runs out. So really describing, hey, this is this mystery like ghost game. You're trying to defeat, in this case, the ghost. It is cooperative, really explicitly said so. Another one down below is this Fury of Dracula. So a game where players must work together, track down and defeat Dracula, and make sure his influence doesn't spread too far. It's really, again, saying how it's cooperative as well as mysterious. And then the last one, again, Shadow the Lid down here. So all 3 ones that are, for people who like mystery as well as cooperative gameplay. And again, very similar to another example we're looking at with the text from the recipes. If you do also want scores associated with it, we can start to hop through some of these different PDFs, which actually even does a good job of highlighting some of the different text used here for this generative response for the different 3 cooperative mysterious games we were just looking at from before. Perfect. So yeah, so really for my portion here, just want to go through an example of more straightforward end-to-end plain text here with those recipes, as well as a comparison with using 2 different methods that you might want to just think about, consider what makes most sense for you as far as using GPT model to fine-tune on top of, do some search that we're doing all in the back end, or just Abacus.AI's own LLM here, some of the different responses we're going to get for the same exact question. And then again, once you're done here, actually probing the custom chat, this is when you can start to look towards deployment and actually integrating this with application script with the API. Perfect. So it really wraps up everything and that we want to go over with our custom chat. A few examples here. Hope everyone's starting to click around, playing with things. You can also, of course, ping us. Just website, go to the front page. Pretty easy to actually, request some additional help. We're happy to try out, one of your own custom chat projects with your own knowledge base that you might want to read over, in addition. So perfect. That's everything on my side, and I'll pass it over to you, Nandish.
Thank you, Miles. Hi, everyone. I'm Nandish. I'm head of product here at Abacus, and I'll be walking you through something called AI agents. I'll go about this in like 3 stages. The first stage, I'll create an agent. So anyone who has already gotten access and signed in using the link, you can follow along with me. The second stage is like I'll go through some of the agents that we have, some simple agents, and show you how the different agents are responding to user queries. And finally, I'll go over something called a data agent. I see a lot of questions about this, like if I have my own custom data, probably like 5 different tables or like 5 different CSV files, how do I answer questions about that data? So I'll go over an agent that can help you answer questions about your data. So yeah, so that's the order that I'll go by. The first thing I mentioned, which is creating an agent. When you log into the Abacus home screen, this is what you see. So if any of you have logged in, you can just follow along with me. So you create a project, create an agents project, and then click continue. And then let me just give it a name. I'm just creating a summarization agent. In this case, you don't need any data sets. You can just go directly and create an agent. You can either open it in a notebook and type the code in the notebook, or as I'm doing, you can just do it in the text box. You already have a template, but I have already written the code somewhere, so I'll just copy that. So just 3 lines of code, and your summarization agent is ready. It takes like a quick second to train, and then we just deploy it, and then we are ready to ask it any questions. So while this is training, I'll actually show something that I already have. I have already trained a summarization agent earlier. So once the agent is trained, you just deploy it, which I'll show once the agent that we just created trains. But in the interim, I'll actually go through the summarization agent and show you how it responds to a few questions. So I have a big blog on AI, and I just want to summarize it. So I'm copying the text from that blog, and so there is a huge blob of text. I don't want to read through all of it. I'm asking the agent to summarize it for me. Just takes a quick second to process. As you can see, it summarized the full blog into like a really short blurb. Seems pretty accurate based on like the article that's here. So the agent, I mean, you have built a summarization agent in like absolutely no time. Actually going back here, okay, the agent is still training. So once you train it, if you're following, once you train it, you get an action here to deploy the agent. You just click the deploy button, and you can deploy the agent and ask questions the way I'm asking it here. Okay, actually the model is trained. You can just deploy it. Yeah, once you deploy it, it takes like a couple of minutes to deploy, and once it's deployed, you get the same page as I got here, and you can ask it any, you can give it any text, and it just summarizes it. Other interesting agents that I will go through are chat like a best friend. So let me actually pull that, like chat like a best friend, John. So I'll go to the dashboard. Let me just type in some conversation. So John, it thinks it's John, so it responds like John. It responds as if he's your best friend, John, and then we can ask it another question, or like continue the conversation. Yeah, and you see it's still responding like John and asking you questions about you and your life and things like that. The next agent that I would go through is a documentation agent. I think a lot of you who are coders here might not like documenting the code, but can love writing code. So you can offload the task of documentation to the model. So let me quickly show you an example. So I have a piece of code that I don't have documentation for, but I want the model to write the documentation for me. So you could just enter the code, and a documentation agent can generate the documentation for the code pretty quickly. It's still taking a little bit of time. There seems to be some issue with this. Let me try again. Just find out. Maybe give it another shot. Okay, in the interim, I'll open a few other deployments. We can try the other agents that we have. We have something called a code explainer. So again, we can try this agent as well. I'll give it some code and see if it explains the code well. I guess a lot of people are trying this, so there's a lot of overload on the model, and it's kind of taking a bit of time to execute. Okay, so at least the code explainer has worked. I finished executing. So in this agent, I gave a little bit of code and I asked it to explain the code. It did a pretty good job at explaining the code. Like it's explained each line one by one. It says like first line, you're importing the library. The second line, you're kind of defining the function. And it's basically explaining each line of code. So you could quickly understand, even if you don't know the language, you can quickly understand like what's happening in the function that I have input here. You can try more complex agents or like, I mean, different kind of agents. One other thing that I personally like to try is a code translation. So if you give it code in Python, it kind of translates it to R and vice versa. That's the instruction that I've given the agent to do. Okay, this seems to. Yeah, so I gave it code in Python, it translated it to R, and I can just do the same, like copy paste the code in R and see if it translates to Python. Yeah, it did translate to Python. So this is a code translator agent. You can try different agents like this. All of these are pretty simple to create. You can just check out the logic for any agent here, code translator, for instance. It's pretty simple. You just tell it, translate code from R to Python or Python to R, and it does a pretty good job at doing it. So these are some simple agents, like nice to have to simplify your workload or nice to play with. Now, the last agent that we're going to go through is a fairly complex one. This is where like all the aspects of the platform come into picture. So it's called a customer 360 data LLM or data AI agent. So to give you more context, what we're trying to do with this agent, we have 9 different data sets. I mean, this is a Kaggle data set, so you can probably import this into a project. It's very easy to create data sets in Abacus. You can just click create data set. You can give it a name. You can either like upload a file or use any of the connectors to get data into the product. So in this case, I just uploaded those 9 files one by one. And here are the 9 different tables that I have in my data. Again, these tables are small in this case, but even if you have like multiple gigabytes of data or multiple terabytes of data, the whole thing works as is. So once you have these tables, what we do is we kind of create a vector store of the metadata of these tables. So it can be referenced pretty quickly. And the agent that I created will be used to answer questions on that particular data. Now, how does that agent work? I'll quickly go through the code. So basically what the agent is doing is first it's using our basically vector store to search through which feature groups are, in this case, the data sets are relevant to the query. And once it gets those relevant tables, it passes the schema of those tables to an LLM and the query that the user has given. And based on that, LLM generates a response, which is executed on Abacus platform, and the results are returned. So this is a slightly complex agent, which involves all aspects of the platform, like feature vector store, data sets, query processing, and so on. So let me go to this deployment and show you some interesting use cases. So I have a few questions that that I'll show. So the first question, like I want to ask, show me the top 10 products by fleet value. So let it answer the question, and then, okay, so it showed these are the top 10 items by fleet value. Now, if you see the query, it's basically, okay, let me actually show you the data sets as well. It's basically querying like one table to get the value. It's a very simple query, but it did a pretty good job at doing it. As you can see, OList order items data, that table has the the data about the fleet value and like the product ID. So it just grouped by the product ID and returned the fleet value. The second query, which could be slightly complex. So I'll ask it, how many products have aggregated fleet value more than 10,000? So in this case, the answer should just be 1, because only the top one has more than 10,000. And then I said, rename this column to total. So let's see what it does. It did a pretty good job of showing this. So it returned like there's only one column that has a total of 1, and it also returned the query. Now we can try slightly few more queries and see how this does. It's taking a little bit of time to process. Okay, it did return the value. So show top 10 products along with their categories aggregated by fleet value. So it has to join 2 tables because the product table has this column product category, and the order items table has the product ID. So it did join both those tables to return this information. Now, product category name is in a different language. It's not in English. Now, let's say we want this to be in English. So I'll quickly show you which table has that information. So there is a product category name translation table that has that has like one-to-one mapping between product category name and product category name in English. So I'm asking the LLM a question to show me the top 15 products along with their product category name in English. So see the difference between the previous query and this. In this, I'm specifically asking, like, find me this product category name in English. So let's see what it does. Okay, it did a pretty good job. So if you see all these product categories have been translated to English. So here it was Informatica accessories. I don't know what that really means, but seems very close to computer accessories, bed, bath, and table, garden tools, and so on. And if you see the query, I did use the product category name English column. It did join with the product category name translation to get this. It's not a simple query. It seems like a fairly decently complex query to get this right. And finally, let's go over another query that's even more complex. So let me go through a very complex query. So this is show me the top 20 orders by fleet value, where product category name in English is health beauty. Show me the columns of fleet value, the status of the orders, the review scores, review title, and review message. So this involves like about 5 or 6 different tables to get this result. And the system was able to do it pretty well. So if you look at the query, it's like very complex query. It would take even an expert data scientist like 5 to 10 minutes to even write this query. And the results are pretty accurate. I mean, it is accurate if you can see the data sets. So just to show you how complex this is, reviews are in a table called orders, I think. Probably, no, not even orders. Yeah, reviews data set. So reviews are in reviews data set. Then there is the order items data set. Then there is the products data set, then product category name translation, because it has to filter for health and beauty. So it had to join like 5 or 6 different tables to get this result. As you can see, the query uses like, I don't know, 2, 3, 4, 5 at 5 different tables to get the results. And it's a very complex query, and the system has done a pretty good job in this. So, I mean, you can create any agents as you wish using the platform. You can get more creative. You can basically create agents that can access the internet, where you query Google for certain results, get the results, and then summarize those results and show. You could use any other third-party data warehouse as well, and connect to that warehouse and like write your own queries, as long as the metadata is kind of indexed or in our vector story should be good. So you could do like any amount of crazy things depending on your creativity. You can create like whatever agents that seem to serve your purpose pretty easily using the platform. Cool. That's all I have for the agents demo. I'll probably hand it over to Kim or Bindu to take over.
Oh, well, actually, I think we are ending a little bit early. Not too bad a thing at a very high level. But yeah, so thank you all for coming. That was a demo of both the chat LLM as well as the AI agents. We do have, like I mentioned before, a free token, which gives you free access to Abacus.AI. You can also go to Abacus.AI, Abacus.AI, that is Abacus.AI, and request either a consultation or ask for an account. We will then basically send you a note with a link to the platform, and or like also try to book a meeting with you. Having said that, like I've said earlier in the webinar as well, we are offering free proof of concepts where we will be actually custom tuning an LLM for you. So this is basically fine-tuning an LLM based on your knowledge base, and or building AI agents, which do a variety of things. So again, thanks a lot for coming. Hopefully you guys will come back. We're going to be doing this a lot more often on top of it. So talk to you guys all soon, and have a really good rest of the day or night, depending on where in the world you are. Bye.